Hi, my name is Dave Haas. I'm a PhD candidate at Duke University Marine Lab in the Department of Marine Science and Conservation. Prior to being in this PhD program, I was the executive vice president of worldwide game studios at a video game company called PopCap Games. We made games like Plants vs. Zombies and Bejeweled. Maybe you played them. What I'm going to be talking with you today about is the union of the two worlds that I come from, a background in technology and computer programming, and my current life involving whales and dolphins, and putting all of those together in a little game demo that I've called Beluga Blast. And the purpose of this is so that I can explore the concept of computer programming with you. So the very basic concepts, like things like object-oriented programming and variables and event-driven programming. These are basic concepts that are common across all types of programming, whether you're trying to make a video game or you're trying to develop a new kind of digital tag that I'm working on right now to attach to the sides of whales and dolphins to measure their heart rate or blood oxygen saturation. So by going through these concepts with you, I think I hope to show you at least that some of these concepts that sound very, very complicated with names you may not be familiar with are very simple concepts, and they'll apply everywhere. And if you learn these concepts, you can take them with you in all kinds of programming directions. So with that, why don't we go ahead and hop in and get started? So before we hop into this, I wanted to go over very quickly some of the key programming concepts that I want to talk with you about today. These include object-oriented programming, variables, event-driven programming, comparison operations, conditional execution, and physics and simulation. I'm going to be talking with you about these in a programming environment, a video game programming environment called GameSalad, and I want to show you that now. So let's begin by actually showing you how to get the GameSalad game programming environment where we're going to be doing all of this work today. If you visit GameSalad.com, you'll come to the main page. And if you click on the developers link up here, it will take you to this page. And they make the claim that you can make your first game in an hour. And actually building the demo that we're using today, Beluga Blast, I found that that's true. If you have some basics under your belt, which you'll have by the end of today's webinar, you should actually be able to put a game together in a very short amount of time. It's not going to be perfect, it's not going to be polished, it's not going to necessarily be beautiful, but it will be something that you can start working with. So when you're ready to get it, you just click on the download now button and you'll end up downloading the GameSalad creator program. And in my case, I'm on a Mac, so that'll be downloading it for Mac OS, but if you're running that on Windows, you could download it for Windows. And then once you've created the game, there's also GameSalad viewers that you can download for iPads, iPhones, Android devices, you name it. There are a bunch of different ways to actually view and play the game that you make on a number of different platforms. So we've gone ahead and downloaded GameSalad already and installed it on this computer. So if we go to here, this is the GameSalad icon, and we'll fire up the GameSalad program. And that takes us to this program here, the GameSalad interface. And I'm going to go ahead and open a recent project. Normally, if you're going to be doing this, you would maybe want to download some demos. You could download Beluga Blast, which we'll be putting up there. Or you could download some others to see if you wanted to make like a penguin, side-scrolling game or something like that. You can also say a new blank project and create it that way. But what we're going to do is we're going to start by opening Beluga Blast. And that will bring us to this screen. So let's start talking through the GameSalad programming environment and make the linkage between object-oriented programming and some of the concepts that we find in the GameSalad environment. So here we have Beluga Blast. This is the version 0.5 copy that we're working with here. I want to first start by looking at actors. So in Beluga Blast, I've created a number of different actors. These are things that exist inside the game that will interact with one another. The first one, of course, is our beluga. This is the beluga whale that will be the hero of the game that the player will control. There are a number of different actors inside the Beluga Blast game, and each one of these actors are what could be considered an object. These are all the creatures, all the power-ups, all of the things in the environment, like corals that might be obstacles, or thrown octopus that might be a weapon that this creature over here, this octopus demon, could throw. Every single thing in the game is basically an object. And what is it? What is an object exactly in object-oriented programming? An object is just something that has data. So it's a thing that contains data. In the case of GameSalad, the beluga actor or the beluga object has different types of data or attributes that make the beluga object or actor specific and distinct from the other objects in the game. Some of the things that make it distinct, for example, are the image, right? So obviously, if you see the beluga, it's not going to have the same image as a shark. So that would be one thing that makes it distinct. Another thing that would make it distinct would be its size. This is another attribute or data type that distinguishes the beluga from, say, a humpback whale, which would be a much larger whale. So the attributes or data are the constituent parts of the beluga object or actor in the language that GameSalad uses. And that's a really, really simple concept. Just objects are actors. Objects contain data or attributes in this system. So the concept of an object can be taken a bit further in GameSalad. And what I want to talk with you about here is the idea of an object, say whales and dolphins. This is a whales and dolphins object. And this object is really a container for a number of other objects. In this case, we have all of the whales and dolphins that are going to appear in Beluga Blast right now. We have 5 of them. And each of these are their own object: the humpback whale, the gray whale, the sperm whale, the dolphin, and the right whale. 5 different objects, each one distinct. Each one has its own image. They all have different sizes, different size data or attributes that make them bigger or smaller depending on what animal they are. But all 5 objects or actors are contained in this whales and dolphins object. And in GameSalad, these are all of the things you see here on the left are things called actor tags. And if you look in the right whale, you'll see the tag is whales and dolphins for this animal. If you look, we have whales and dolphins is one container object, but we also have sharks. And right now we have 3 objects in here. There's a great white shark, a hammerhead shark, and then a copy of a hammerhead. We made a copy of this a little while ago. And I'm just going to get rid of this because I want to demonstrate very quickly another concept that we can take from object-oriented programming and demonstrate here in GameSalad. So right now we have 2 objects, a hammerhead shark and a great white shark. Both of them are objects within the shark's object container or actor tag here. What I want to do though is I want to demonstrate something we call prototyping. So right now we have a hammerhead shark object, and we can use that as a prototype for another object that will inherit. This is the concept also of inheritance. So we have the idea of a prototype. Here's an object. We can make a copy of it, which we just did, and use that prototype to pass on the data or the attributes that the hammerhead had onto another object. And that concept is inheritance, the inheritance of the data or the attributes that made the hammerhead shark unique get passed on from this prototype, the hammerhead shark, and are inherited by this hammerhead shark copy. Now what we're going to do is we're going to change this copy of a hammerhead shark into a bull shark. So we give it a new name. But we need to do more than just that, right? This has a different image than a hammerhead shark. We don't want a bull shark to look like a hammerhead. So we need to go in. We've got a library of different images that we imported in when we started this project. And we want to get the image of the bull shark and replace the hammerhead image here with the bull shark. So we can get rid of that. And then you can see the drag image here. We can literally just drag the bull shark image up here, and voila, we have a bull shark now. It's currently the same size because it inherited the size of the hammerhead shark when we created the bull shark from the hammerhead shark prototype. So it's inherited the size, and we can keep the size the same, but we want to give it its own name, bull shark. We have that. The size is fine. And now the image is there, and it is a member of the shark's tag. So that's great. And now when we look in our sharks container object, we have not 2, but 3 distinct kinds of sharks. So this is, again, the idea of objects, 3 objects, a container object that contains 3 objects, and then the idea of taking a prototype of something, in this case, a copy of a hammerhead shark, and then pasting that in and letting that new object inherit the properties or the data or the attributes, and then customizing it in a way that we see fit while keeping all of the original object's properties, other than the ones that we wanted to make distinct. This is really nice because it's so easy to make a new object. You can copy. So if you go here, copy, and then paste, it's just that easy to make a new animal. So if we wanted to add a 4th kind of shark, I'm not sure what kind we'll do here. So let's say shark, and then let's go into this object, and we're looking at images, and I'm pretty sure I added, there's a whale shark, but I thought we also had another kind of shark in here. So let me just have a quick look through here. Hammerhead, great white. Maybe that was it. Bull shark. All right, so let's just go ahead and make a whale shark. Whale sharks are big and beautiful. Oh man, that's not what I meant to do. Big, beautiful animals, so they need to have a bigger size. And a new name. Great. So now we should have in our sharks container object, great white, hammerhead, bull, and whale shark. Similarly, we could do the same thing here. If we wanted to have a new type of whale, say that we wanted to add a blue whale, we could use the humpback whale, which is a type of baleen or filter feeding whale, as a prototype object, and do a copy and paste and create a blue whale. And then we can actually reuse the graphic of this, but just say we're going to make a blue whale, which is the biggest animal to have ever lived on Earth, that will be 500 pixels long by 135 pixels wide, and we'll make its color distinct. In this case, not very much red. You can change the numbers between 0 and 1. 1 would be full red, 0 would be no red at all. We'll add some green and quite a bit of blue for a blue whale. That looks pretty good. And alpha means that the background will be transparent. And now, if we look at our whales and dolphins, voila, we have a 6th whale, the blue whale, that's distinct. 6 objects in our whales and dolphins class of our whales and dolphins tag. So we have this whales and dolphins container object with 6 objects in it. So what we've demonstrated here are the idea of objects, things that contain data or attributes, container objects, which can contain multiple objects themselves, and the idea of prototyping, taking one object and letting another object inherit the properties that came from that prototype. So a blue whale that looks like a humpback but is much longer and has a different color, or a shark that came from a hammerhead but has a different graphic but is identical in every other way. So next up, I want to talk about the concept of variables. Many of you probably already know what a variable is, but I'd like to revisit it in the context of object-oriented programming and in the context of game development inside GameSalad. So let's begin this section by understanding the idea of scenes. Scenes are the place where all the action takes place in GameSalad. And in this very simple game prototype we're developing for Beluga Blast, we're only going to have one scene, the initial scene. So we select scenes, and then there's this initial scene. Right now, it is empty. There is nothing taking place. It's just a blank canvas for us to basically create our video game world. So the first thing we need to do to the scene is add a background to it. So we can just drop in a background graphic here and stretch it out so that it takes up all of the space available. Great. We can hit this play button here, preview, or here, and see how does our environment actually look. And that's great. That's just what we need it to look like. And then go back to the scene. Good scenes. There's our initial scene. So this is the canvas that we'll paint our video game on. We need to add some actors to it. So the next thing we want to do is go click on game again, and then we have all of our actors that we've created. So here's our beluga. So let's add our beluga hero that the player will control. And then we created some whales. So let's add in a right whale. Right whales are shallow water animals. They spend almost their entire lives in the shallow parts of the water. Let's add in a gray whale also over here. We created some sharks. So let's add in a shark. There's a great white facing off against our beluga whale. And a hammerhead down lower. And then here's a dolphin. And then what else we added? We created a blue whale, didn't we? Where's our blue whale? Probably down at the bottom. There's a big old blue whale. Great. So this is great. We've just added some objects, a beluga, right, gray whale, dolphin, gray white shark, blue whale, hammerhead. And if we do a preview of it, things just kind of start moving. We have our beluga whale that can swim around, can bump into other objects, can knock the shark out of the way. So that's a start. Not very interesting. There's not a lot of tension here. So one of the ways to address this lack of tension is to add an end game condition. And most end game conditions are something like the player dies, runs out of health points, or faints, or sometimes just reaches the end of the game. Like there could be a conclusion point for the game, and at which point the game ends. So for us to deal with this in Beluga Blast, we need to find another way to scale up this dramatic tension a little bit. And a way that we want to do that is to add some variables for things like beluga health. And because belugas are air-breathing mammals, just like we are, as are all whales, we think about adding something like beluga oxygen, so that the beluga has these two different game mechanics that have to be managed by the player, where making sure that the beluga keeps its health above zero, which can be an end game condition, and keeping the beluga's oxygen above zero, which can also be an end game condition. So let's figure out how we can do that inside of this game. So in Beluga Blast, what we want to do is create a couple of variables for beluga health and beluga oxygen. And these are variables that need to be accessible not just to the Beluga object, but to the entire game itself. There can be things that happen inside the game that need to affect Beluga health. So that type of variable is different than a normal variable. So there may be variables that affect only the object itself, and those would be sort of a different kind of variable than this one. What we're trying to do here is to add two variables called Beluga health and Beluga oxygen that would be known as global variables. And these are variables that can be seen by all the objects in the entire game. So here's a Beluga health variable that has a value set to 100 to start with. And it is a variable of a type called integer. Integer is really easy. It's just 1, 2, 3, 4, 5. It's a whole number. There are a number of different variable types that can exist in computer programming and in GameSalad. Some variables are things like text. So you can have a word, like an actor tag for the Beluga is Beluga. And that is a type text. It's just letters or word or words. There can be other types like real numbers. Real numbers are just variables that could be like 3.5 or 4.25, things that have a decimal or a fractional component to it. The important variable that we're concerned with right now, though, is Beluga health and Beluga oxygen. These are going to be two game mechanics that create tension in the game and make it interesting so that you're not just swimming around endlessly waiting for something to happen. So let's go ahead. We've added Beluga health here with the starting value of 100, Beluga oxygen with another value of 100. And let's try and do something interesting with that. So we've set our Beluga health and Beluga oxygen global variables at 100 each. Before moving on, I wanted to say I mentioned global variables. These are two global variables that are accessible to every object in the game. There are different kinds of variables. There's like what a more normal variable might be. I'll give you a quick example of that. So size is a great example of a variable that is not a global variable. This is a variable specific to the Beluga object. The size is 100 pixels wide and 55 pixels wide. So these are called variables that are local or specific to the Beluga object. And that difference in a set of variables that are contained in the object are called encapsulated variables. It's this object-oriented programming concept of encapsulation, that these variables are variables that only specifically affect the object to which they belong. So the Beluga size, these are two variables that are only specific to the Beluga object, whereas the Beluga health and the Beluga oxygen global variables, those are global variables. They're not encapsulated, not specific only to that object. So that's just a really quick distinction that I wanted to point out to you. All right, so we have Beluga health and Beluga oxygen. We can do something very interesting with this now. So let's go back to our actors. So there's our actors, there's our Beluga actor. And let's set up a couple of interesting conditions here. So we have Beluga health and Beluga oxygen. And what we can do is say, here's a couple of conditions we can manage around oxygen use. So every 6 seconds, we can change an attribute or a variable. And in this case, what we've said is every 6 seconds that the Beluga whale is swimming around, change the attribute Beluga game.Beluga oxygen. That's our global variable for Beluga oxygen. And what are we going to change it to? And this is a variable redefining itself, right? So what we're saying is every 6 seconds, game.Beluga oxygen, the Beluga oxygen global variable, gets 10 subtracted to it every 6 seconds. So after 60 seconds, you would end up having the value would go down to, what would that be? Every 6 seconds times minus 10 would be minus 60. So this is a way of basically saying as the Beluga is diving around underwater, it's burning its oxygen up. And that's going to get really critical after a minute and a half, and you're going to have some big problem come up. We can also look at that. So here's the Beluga oxygen game variable again. So we've said a death condition around that global variable. So when any of these two conditions are valid in the game, when Beluga game health is less than or equal to 0, basically when it gets to the 0 point, or if something bad happens and it takes it to a number below 0, like -10, or when oxygen gets to 0 or some negative number, -10, -15, whatever it is, that those things can cause a death condition to be specified for the end of the game. So that you've got destroys the actor. It gets rid of the Beluga object in the game. It spawns an end game graphic, which is pretty ridiculous when you see it. And then it ends the game. It quits the game. So these are ways that you can use variables to control the flow of the game. So we've established a death condition that can come from running out of health or running out of oxygen. We've set something up so that as the Beluga is swimming, every 6 seconds, 10 points of oxygen are taken away, so that after 1 minute, the Beluga will be out of air. We've also done some things here with Beluga game health. Right now, we wanted to say, okay, sharks are a danger to the Beluga. So let's set up a condition where as the Beluga is swimming around, it can be bitten by a shark. So we've created this rule. This is a rule. We can create rules by doing clicking this button, and it will create a rule that looks like this. And it says when some condition is valid. So in this one, we just have the one condition. When all conditions are valid, that the actor, the Beluga object, receives an event, and that event is overlaps or collides with, and then with an actor of the tag type shark. So if it runs into a great white shark, a hammerhead shark, a bull shark, or a whale shark, that we have that collision with the shark change the Beluga health and have it be set lower. So it's taking Beluga health, whatever it is. So it starts out at 100, and then it will randomly take away between 20 and 40 health points from the Beluga. So this isn't something that always is the same. By using random, we can say every time the Beluga collides with a shark, it takes away between 20 and 40 health points. If we think that that game mechanic is too unfair or makes it not very much fun for the player, we can change that to maybe 10 to 30. But this, using these expression editors and rules, allows us to quickly play around with how we think that feels and what we should do to balance the game and make it feel good to the player. And then typically, if there's some kind of a negative thing happening to the player, we should set up some kind of an alert. So here I've created something called particles. So on the event of a shark bite, we take away the Beluga's health points using the global Beluga health variable and this expression that we've set up to take away 20 to 40 points every time that happens. And then we also have the Beluga emit some little dot particles that come out of the Beluga. And I've made these just little tiny dots that are red in color, like it's being bitten by a shark. And we can use that to let the player know that they've been bitten by a shark. So we've got some basic things happening here. And if we swim around now, we can bounce into that guy. And now we run into a shark, and you can see some red particles coming out. So the user knows something bad has happened. Unfortunately, the user doesn't know that they don't actually know how much health they have left, and they don't know how much oxygen they have left. So there's our ridiculous Beluga endgame graphic. The game is over when the Beluga runs out of health or oxygen. So I just went and ran into a hammerhead shark, and it took away the last of our health. But we have no way to look at this and say, oh, I was down, I had needed to be more careful. So how can we address that and add some kind of a graphic in? I've created a couple of other actors or objects, Beluga health and Beluga oxygen. These are I've created those, and I've created a group an object container for Beluga Health and Beluga Oxygen status displays. And what these do is they set their graphics, they're 200 pixels across by 20 pixels high, and they have their width set by, this is the health one, so game.beluga health, the global variable, when it's at 100, this will look 100 pixels wide. And when this one, this is taking a little more, the Beluga Oxygen is the same thing. It sets its width based on the game Beluga Oxygen. So these refer back to the global variables, and this is why these variables need to be global, so that if it was just the Beluga we cared about, that would be one thing, but these are status bars that we need to put into the scene so that the user can have some kind of feedback when the Beluga is hurt or when the Beluga is running out of oxygen. So let's go ahead and take those status bars that I created and add those into our game. So this is our scene. So we're going to add a status bar down here for health and a status bar over here for oxygen consumption. And that's pretty close. Maybe not perfect, but probably good enough for now. And then let's preview the game and see how this is running. So now we have a health bar and an oxygen bar, and we'll run into that guy. Okay, now we just ran into the shark, and you can see that the health bar just changed its size. So as we're swimming around, and then you can see here the oxygen bar just decreased by a certain amount. And as the whale swims around, as the beluga swims around underwater, this will continue to shrink because the whale is slowly running out of oxygen. So we also have to create a zone of some kind so that when the beluga goes back to the surface, that it can get some kind of oxygen fix. So how are we going to do that? This is another way. We need to basically create another object. So I've gone ahead and I've created some different zones. But one of the zones I've created is a zone that's called surface. It's a surface object. It doesn't have an image. It's just a transparent big space that we wanted to put into the scene somewhere. And this is another rule. So we would create a rule that whenever the actor, the beluga, encounters this box, this actor is the surface actor, right? So the surface actor receives an event where it overlaps or collides with actor of type beluga, that it will change the attribute of game.beluga oxygen. That's our global beluga oxygen variable, and it will put it back up to 100. So the idea here is if we put this transparent object, this transparent surface object up at the top of our scene, that we should be able to have the beluga go back to the surface here. So this is our object. This is our surface object. I'm going to delete it really quick and just show you what it looks like to put it in. So we find that surface object again here, and we drag it over, and we can just click on it, and then we'll stretch it all the way out. So if the beluga goes anywhere in this area, it will set its oxygen back to 100. To 100%. So let's save that, and now let's do a preview. So our beluga swims around, gets bumped by the blue whale. Let's have it go over here and get hurt by a hammerhead shark. You can see the little health bar just dropped by some amount. And then I'm going to let this go just a little bit longer. So you saw it shrink down there. So get around our right whale here and then come back up to the surface. And you can see that the bar expands in size. So we have a really basic oxygen and health thing here. Now we've also got a problem that once everything is off the screen, there's nothing happening, and there's absolutely no fun in this. So we've got to fix that problem next. So this brings us to the final section that I want to cover, which is around event-driven programming concepts. So we have this game where our beluga can swim around in this area, and A couple of things happen because we put some animals on the screen. But once everything is off the screen, the game is very boring and we need to make something interesting happen. So one of the ways we can do that is to use something called spawning. And the idea of spawning is if you have a scene, like our scene here, you can create spawn zones that exist over here, sort of off the screen someplace. Here's one. There are basically these sort of transparent ideas, transparent objects, like our surface one that creates an oxygen zone for our beluga whale. But you could have a specific spawn zone that would allow for a dolphin or a shark or a gray whale or a blue whale or some other animal or some other object to come into the game from time to time. And these are event-driven programming spawn zones. So the idea of spawning an object or creating an object and introducing it into the game based on some event is how we accomplish that. So I want to go back into our actors, our objects list, and I've created a bunch of different spawn zones here. There are a total of 9 right now. So we have a shark spawn zone, and in this particular shark spawn zone, this is an event-driven zone, so it's a transparent area that we can put anywhere on the screen. And this is a great white shark spawning timer. And what this is this is an event that randomly happens every 15 to 25 seconds at random. And when that happens, it will cause this event called spawn actor, which is the introduction of a great white shark actor or object to come into the screen somewhere, to come into the scene that we have. The shark will come in with pointed in the direction. That's the direction that it is pointed normally, which is pointed towards the left. And it will always come in at position 1024, which is the rightmost edge of our scene. And it will randomly appear somewhere between 15 and 700 pixels on that left side of the screen. So what does that mean practically? It means that if we put a shark spawn zone, so if this is, let's just delete this, but that's probably our shark spawn zone. But I'll show you what it looks like to put it in. So there's our shark spawn zone, and we can drag that transparent rectangle in and just drop it in over here. I don't know why it went there, but that's okay. So what's going to happen now is this shark spawn zone is there. And as the game progresses, as the game goes, every 15 to 25 seconds, a shark will spawn in somewhere beginning at 1024, which is this area here, and somewhere between 15 pixels and 700 pixels. So anywhere randomly, every 15 to 25 seconds along this line, that shark will appear now. So this is great. So now we've got something going on. Our beluga can swim around, and this is all going right. Knock that shark out of the way and be careful because that's gonna knock that shark back. And hopefully we'll see here within 15 to 25 seconds, that shark should spawn in. And sure enough, there we go. So now we have some action happening. We've got some event-driven programming causing a shark to spawn in every so often. This is very good for keeping the game interesting. So now we have to add in spawn zones for a lot of different objects. And to make this get really interesting, we can add in, like I said, I created some in advance because it's just basically what I showed you before. We can just take the shark spawn, use that as a prototype, and then copy it into a bunch of different things that cause a dolphin to come in, another humpback, a sperm whale, a gray whale, and a right whale. And then to make the game even more interesting, so you keep getting damage from sharks whenever they bite you, we can also add in a couple of fish. So I've added a heartfish here that I've colored red, and this fish will come in and drop a heart. So the idea is we've created a rule. This is another type of conditional programming, a conditional execution. So what this says is I've created a rule for the heartfish that when the heartfish, the actor of the heartfish, overlaps or collides with an actor of type Beluga, it gets rid of the heartfish and leaves in its place, it spawns an actor or creates a heart object that ends up slowly falling down towards the bottom of the sea at a random speed between 50 and 100, and it always points down. So what this does is now whenever we add, so we've created a heartfish. The heartfish will drop a heart. The heart is also an object. And the heart, when it's dropped, is also a conditional expression. So we've created a rule for the heart. And it says that when the object heart, when the actor heart overlaps or collides with the Beluga, that it will change the Beluga health global variable so that it increases plus, and it increases the Beluga health randomly between 5 and 10. And we could just set that, if we don't think that's fair enough, we could say between 10 and 15 and make it a more powerful power up for the Beluga. So we've created a heartfish, we've created a heart. So the Beluga runs into the heartfish disappears, it leaves in its place a heart that the Beluga can then go and collect, and when that happens, it will increase the Beluga health global variable by 10 to 15 points. And to make that interesting, we have to have more heartfish come in because more sharks are coming in now. To keep the game balanced, heartfish also have to come in. So what do? We create a heartfish spawning zone, just like we did a shark zone. And a heartfish will randomly come in now, not as often as every shark. Let's make it a little bit more tense. Every 20 to 30 seconds, a heartfish will spawn in, again, somewhere on the rightmost side of the screen, somewhere between the bottom and the top. And we can go back into our scene and say, where was the heartfish spawn zone? Is right here. And we can drag that in and drop that over here somewhere. And sure enough, there it is. And now every 20 to 30 seconds, if our Beluga is injured by interacting with sharks, ouch, 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 hopefully a heartfish will pop in within the next 20 seconds or so. And can go back up to the surface and replenish our oxygen. Great. Where's the heartfish? There it is. And now we have to catch up to it because it swims fast to make it interesting. Get that, get the heart, and it gives you a little bit of health back. So now we have health can go up and it can go down. It goes down if you get bitten by a shark. It goes up if you can get a heart. And we also have oxygen. And it looks like we have some invisible object coming into. Oh, there's a shark trying to get us. So this is good. We have a few things happening here that are interesting. We have some conditional executions happening. So sharks pop in, heartfish pop in, and those are very good for the game balance. So yeah, we've looked at a few things there. I think a couple of other final points that we want to go over. So we've said these are now have some event-driven programming things where things happen at a time period. Things happen conditionally. So let's go over a couple of conditions that we've introduced into the game. So a great example of a conditional situation we have is this. So we have... so a conditional thing would be the shark. So we have a great white shark. We're looking at conditional things that can happen one way or the other. And this is a conditional execution. So the idea of conditions is that you kind of have this, if something happens, do this, otherwise do that. And in this condition, we've said for our great white shark that we have a rule. This is a conditional execution statement. So the rule is that the shark will come in and it will have, by default, it will have some motion, some physics to it. So it comes in swimming at a speed of -10. That makes it move from left to right. And when it comes in, it will just continue to swim from left to right. But if the shark object or actor receives an event that is an overlap or a collision with an actor of tag type whales and dolphins, that it will collide. And when it collides, the collision action is that it will bounce when colliding with those actors. So what this does is this is a conditional statement that causes the shark to stop swimming directly from left to right when it runs into a whale. And again, you can see this happen with, let me see if I can cause that to happen. No, it's too hard to get it done in time. But the idea is that if a shark comes in and runs into one of these guys, that it will bounce. So let's see. Yeah, I can't do it right now. So I wish I could get one of these, but we just don't have enough. We don't have enough whales. But let's see if I can do a restart really quickly here and cause the blue whale to do this. So the blue whale is too big to move. Better way to do this, because we can easily change things around. So what happens if the blue whale is in front of the shark and the shark moves faster? So there it is right there. So you can see the shark is backing up because it's bouncing into, but it's also not bouncing right now. And what it wants to do otherwise is basically just keep swimming. So it initially bounced into and changed direction when it ran into the whale because of that conditional expression. So again, this is the idea of conditional execution. So the normal case, the otherwise case, when it's not bumping into a whale or a dolphin, is for the shark to basically just keep swimming and slowly randomly changing its speed. So it will just change. It starts with an initial speed of -10 moving from left to right, and it will randomly just sort of change its velocity from time to time. So this is so this way you can end up having sharks that come in with different speeds. So not every white shark always swims at -10. It will randomly change it to be -30 to -100. -30 is slower, -100 is faster from left to right. So there's a good example of a physics interaction, and another good one coming up there with a shark. But the shark always basically just wants to keep swimming from left to right, even if it gets bumped. So there's some good conditional execution things. The final topic I think I really wanted to cover today was the idea of comparisons. That we have these great variables. We have a great global variable that we use for our beluga. So and we use that condition. We use we use a comparison operation to decide when the game is over. So when the beluga dies, either of these two conditions, being the beluga health or the beluga oxygen, being less than or equal to 0. So that's a comparison operation. And it says that when that comparison is, when either of those conditions are valid, when either health, beluga health, or beluga oxygen are equal to 0 or less than 0, become a negative number, that these three actions will take place, resulting in the destruction of the beluga object in the game, resulting in the spawn actor of the game over graphic, and ending the game. And in that way, we bring the game to a complete close. So hopefully you can see how we've been able to take all of these concepts and actually create a pretty okay first attempt at a video game. So this is Beluga Blast with all of the spawn zones in. So lots of animals are coming in all the time now. I've added a money fish that drops coins, and you can go and collect the coins out of the water. The idea being that you could eventually buy some power-ups. You've got some sharks coming in all the time. I've added a mystery octopus demon guy who throws some octopus at you, and those hurt if they hit your beluga hero. So yeah, the basic mechanics that we talked about, it's all in there. It stays pretty busy. There's some animations now when you swim through this, some bubbles pop up. So yeah, it's turning into a more interesting game. And basically taking all of the ideas that I presented here today, you can just continue to stack these ideas up and find a way to balance the game and make it interesting and fun and challenging. You can have extra stages that come in later where you can add different animals, different whales, different types of sharks, different weird octopus demon things, throwing squid or cuttlefish, or having corals that sting instead of emit bubbles. It's basically, at this point, you have enough tools using GameSalad and the techniques that I've taught you today. You should be able to make a very basic video game that you can play and enjoy and sit there and experiment until you find a really good, fun game mechanic. And then finding a way to make that fun to play from second to second, minute to minute, hour to hour is how you could maybe create the next Plants vs. Zombies game. So that's it for today. Thank you for listening. I hope this was instructive. I hope you learned something about computer programming and making a video game. And I hope you'll take a chance to play with the GameSalad stuff to try out your own ideas. It's a pretty easy and interesting thing. And I think with all these concepts, you could really put a game together in about an hour. So give it a shot and see what your imagination can come up with. We'll be opening up the questions and comment section of the website. So if you have questions for me, feel free to post them there. And if it helps or makes sense, we can do a live session follow-up in the days or the weeks ahead. Okay, well, that's it for today. Thanks a lot. Take care. Bye.